Hi everyone. So in this video we're going to look over the next three laws just to sequence to the previous video of sum and difference law. Okay, so let's start with the definition of constant multiple law. The limit of as x approaches to a constant times a function is the constant times the limit of the function as x approaches to a. And next one is product law. Limit as x approaches to a of a product is the product of the limits. Is the product of the limits. As such, x approaches to a of fx times limit as x approaches to a of gx. And third one we're going to look in this video is quotient law. The limit of a quotient is the quotient of the limits and how do we write this? Fx over gx is equal to limit of x approaches to a of fx divided by limit as x approaches to a of gx. If making sure as x approaches to a, limit as x approaches to a of gx is not equal to 0, right? Because otherwise it would be undefined. The denominator cannot equal to 0. Okay, let's look at a quick example. Okay, let's look at this example. Limit as x approaches to 2 of 3 of fx over gx. And we have given that limit as x approaches to 2 of fx is equal to 4. Limit as x approaches to 2 of gx is equal to negative 2. And limit as x approaches to 2 of hx is equal to 0. So based off the criteria that we have, so looking at this very first example, limit as x approaches to 2, 3x over 3 times function divided by gx. And just looking at this, you can see, in the first, even though the quotient law is going to apply on this limit, but in the numerator, we can see like constant multiple law is being applied here. So how do we write this? This is equal to limit as x approaches to 2, 3 times fx divided by limit as x approaches to 2 of gx. So applying the constant multiple law in the numerator, we get 3 times limit as x approaches to 2 of fx divided by limit as x approaches to 2 of gx. And since we have already given that limit x approaches to 2 of fx is equal to 4, so this would be 3 times 4, or you could write it as this, divided by limit x approaches to 2 of gx is negative 2. So this is 4 times 3 is 12, 6. This is equal to negative 6. And so as you see, limit as x approaches to 2 of hx is equal to 0 is unnecessary to solve this example. So let's just get another example just to show you quickly. So limit as x approaches to 2 of gx divided by hx. This is equal to applying the quotient law, right? So limit as x approaches to 2 of gx divided by limit x approaches to 2 of hx. And we have given that limit x approaches 2 of fx, oh sorry, my bad. Limit as x approaches to 2 of gx is equal to negative 2. And we have also given that limit as x approaches to 2 of hx is equal to 0. So here, since 0 is in denominator, this is undefined. So in this case, the answer would be undefined. Okay.